host box CSC, and in the series of data warehousing lectures, this is the second video for the cluster analysis only. Okay, and the continuation of the previous topic. As I told you, there are two types of data in the cluster analysis. Two data structures can be used. One is the data matrix and second one is the dissimilarity matrix. Data matrix is the normal matrix which consists of rows and columns, and in this rows, all the rows are the number of persons or number of items or number of objects, and the columns are the features of that objects or attributes of that objects or the measures of that objects. If you take x1 to xn are the persons, and x1 to xp, p are the measures or the attributes of that. If you take measures, can be like something like height of a person, weight of a person, color of a person, age of the person, and gender of a particular person. All these are the measures. Okay, and second way of representation is something like dissimilarity matrix. In this, as already told you, all the diagonal values will be of 0 because there won't be any distance variation between distance of 2, 2. That means the same object difference will obviously be 0. Here we are going to calculate the distance d of 2, 1, the distance between second object and first object, the distance between third object, first object, the distance between third object and second object. Okay, and the distance between third object and third object is obviously 0. The distance between second object and second object is 0 again. Excuse me. And the upper part of this matrix is not being represented because distance between 2, 1 is same as distance between 1, 2. So no need of representing that again. Distance between n, 1 is same as the distance between 1, n. As I told you, the distance between Madanapalli to Angallu calculation is enough. No need to calculate it the back again. That is the distance between Angallu to Madanapalli. Okay, and types of data in the cluster analysis. The data matrix is often called as a two-mode matrix. The dissimilarity matrix is called as a one-mode matrix, and many clustering algorithms operate on the second method, that is dissimilarity matrix. If data is presented in the first form, that is data matrix, it can first be transformed into dissimilarity matrix before applying such clustering algorithms. Objects are described by interval scaled variables, binary variables, categorical variables, ordinal variables, ration scaled variables, and etc. Today we are going to see, in this session we are going to see the parts of the interval scaled variable means, binary variable means, and all these things. Okay, first one, interval value variables. These are nothing but the numerical variables of something like height, weight, latitude, longitude, weather, temperature, and all these things. Okay, and this interval scaled numeric variables are continuous measurements on a roughly linear scales. The problems with this is, for example, changing the measurements units from meters to inches for height or kilograms to pounds for weight may lead to very different clustering structure. To overcome this, we need to do data standardization. Expressing a variable in smaller units will lead larger range for that variables, and thus a large effect on the resulting clustering structure. To help avoid dependency on the choice of measurement units, the data should be standardized. Standardizing measurements attempts to give all the variables an equal weight. To standardize measurements, one choice is to convert the original measurements to unitless variables. Okay, and for doing this data standardization, we have two methods. One is the calculating the mean absolute deviation, and second one is calculate the standardized measurement. Okay, and no, this is a two-step process. First one is by using this SF is equal to 1 by n x1 of f and m of f, where mf is nothing but the 1 by n of x1 of f plus x2 of f up to xn of f. Okay. Next, dissimilarity between these objects can be calculated, can be measured by these three things. Yeah, first one is Euclidean distance, the most popular distance measure, where distance of two objects is calculated something like x of I1 minus x of, that is object of first object minus second object square, plus like this we are going to calculate. Okay. And second method is something like a Manhattan or a city block distance, another well-known metric also. And let us see example for this. Let us take two objects, x1 and x2, and their corresponding values 1, 2 and x2 values are this one. Okay. Now through the Euclidean distance we get the value of something like 3.16. if you substitute these values into our formula, what is our formula? X of I1 minus x of j1, taking the first values in the second one minus the taking the first value in the first object. Okay, like this we need to substitute the values, and after substituting and taking we will be getting these two measurements. Okay. And Minkowski distance, a generalization of both by combining both these techniques. Okay. That is both things, where q is the positive integer and it represents the Manhattan distance where q is equal to 1, and Euclidean distance where q is equal to 2. Okay, this is what basically this interval based values are nothing but the numeric values, and this has to be standardized to remove the unnecessary conversion units. Okay, like converting measures to converting kilograms to pounds will give the unfeasible solution. So we need to remove all those, and we need to make the data standardized. And for calculating the dissimilarity we have two things, Euclidean distance and Manhattan distance. We have the formula, and substituting these values into the formula, and this is the generalization of using both the techniques again. And second one is something like a binary variables. In this binary variables we have two things, one is symmetric binary variables and second one is asymmetric binary variables. Symmetric binary variables is something like gender can be a symmetric binary variable which have the males and females almost same or approximately similar values. And asymmetric binary values is something like for suppose if we have 100 records, 100 data items. Okay, symmetric binary variable means gender, as I told you, a few, at least 50% will be the male and other 50% will be the females. Asymmetric binary value means something like we have a cancer test. Out of these hundreds, only 1 or 2 may be the chance of getting the cancer. Okay, those type of things we call it as a asymmetric binary variables. Or out of this 100 records, there will be a very less of chance of having physically challenged people. That type of attributes we call it as a asymmetric binary values, which is generally having only two states. One is 0 and second one is 1. A binary variable is symmetric if both the states are equal value and carry the same weight. That is, there is no preference on which outcome should be coded, that is 0 or 1. Okay, and a contingency table for this binary variables. We have the two objects, one object is I and the second object is 0, and we have represented with the different values something like q, r, s, q plus r and all these things. We'll try to see what is this q and all these things. Okay, q. See, here we have the q, here we have two objects and object I and object j. Okay, and this is the formula for the symmetric binary dissimilarity, and this is the formula for the asymmetric binary dissimilarity. Okay, Coming to the q is nothing but q is the number of variables. Q is the number of variables that equal 1 for both objects I and j. Okay, and r is the number of variables that equal 1 for object I but that are 0 for object j. I am repeating, for r is the number of variable that equal 1 for object I but that are 0 for object j. And coming to the s is the number of variables that equal to 0 for object I but equal to 1 for object j. T is the number of variables that equal to 0 for both objects I and j. P is the total number of variables. P can be calculated as P is equal to q plus r plus s plus t. Okay, T is the number of variables that equal to 0 for both objects I and j. Q is the variable both I and j are 1. Okay, R is the variable where first object I is 1 and object j is 0. S is the number of variables equal to for object I 0 and object j as 1. Okay, dissimilarity between binary variables. Dissimilarity between binary variables. We have the example here, and the examples are something like Jack, Mary and Jim, and we are going to calculate the distance between them. Just substitute these values into our the formula. We'll be getting the result of 0.33 and all these things. Third type of variable is categorical variables. A categorical is the nothing but a nominal variable. Is a generalization of binary variable. In binary variable, generally we have only two things, that is male or female, yes or no, positive or negative and all these things. Categorical is something like an enhancement for the binary variable which will have multiple values, something like red, yellow, green, pink, which is again a limited only. It is not like unlimited values can be kept into that. Okay, the states can be denoted by letters, symbols and set of integers. The categorical values, dissimilarity between the categorical values, we have the method called simple matching. What this dissimilarity between two objects I and j can be computed based on the ratio. What is that ratio? D of ij is equal to p minus m by p, where m is the number of matches, that is the number of variables for which I and j are same state. P is the total number of variables. Weight can be assigned to increase the effect of m and assign the greater weight to the matches in the variable having the large number of states. Example will be taking dissimilarity matrix between these things. Okay, now we need to calculating the dissimilarity matrix. This is the object identifier and this is the test categorical. We have three tests, basically A, B, C, and the fourth one again it is the A only. Now we need to calculate the dissimilarity matrix. As you have seen the formula, what is the formula for dissimilarity matrix? D of ij is equal to p minus m by p. Okay, if you understand what is m here, number of matches, and what is the p here, total number of variables. Yeah, now if we substitute this into our variables, we'll be getting something like, if you take this one, yeah, I hope you have remember our first matrix, first dissimilarity matrix. Yeah, this is how we represent distance of 2, 1, distance of 3, 1, distance of 3, 2. Like this we can compute. Okay, coming to in our example, we will be calculating distance of 2, 1, distance of 3, 1, distance of 3, 2, distance of 4, 1, distance of 4, 2, distance of 4, 3, since we have four objects. Okay, now substitute these values and distance of 2, 1. If we calculate the distance of 2, 1 and substitute into that variables, that is total number of variables is something like 3. Yeah, Since here we have one categorical value test1 where we set p is equal to 1, okay, and it's like 1 minus m is nothing but the number of matches by 1. This is what we get. Why we got 4 comma 1 as 0? Because fourth one, if you see here, we have code A, which is again similar to first object value 1. Okay, this is about the categorical values. Since up to here we have discussed about 3 variables: interval scaled values or interval values, and second one is binary variables, and third one is categorical variables, and fourth one we also have the ordinal variables. The discrete ordinal variables resembles the categorical variables, except that m states the ordinary values are ordered in a meaningful sequence. Example like professional ranks are often enumerated in the sequential order, such as assistant, associate, and full professors. Ordinal values may also be obtained from discretization of interval scaled values by splitting the values in the range into a finite number of classes. The value of ordinal values can be mapped into ranks. Suppose that ordinal value f has mf states. The ordered states can be defined ranking from 1 to mf. Okay, and we have the formulas and the list of steps also. We'll see with an example. Suppose that we have the sample data and there are 4 objects with 3 values: fair, good, excellent. So the mf will be 3. Okay, yeah. Step 1 is, we have 3 steps. We first replace each value of test2 by its rank. We have assigned the rank. 4 objects are assigned with the rank 3, 1, 2, 3. If you see the values, 1 is assigned for fair, good is assigned with 2, and excellent is assigned with 3. Okay, so the ranks will be 3, 1, 2, 3 respectively. Normalize the ranking by mapping the rank 1 to 0.0, rank 2 to 0.5, rank 3 to 1.0, and we can use, say, Euclidean distance, which results in the following dissimilarity matrix. So like this we can also calculate the ordinal variables also, right? Next one, clustering approaches, which will be covering in the next series of lectures. Thank you